In this video, we are going to talk about the law of mass action. And basically, this is chemistry, and since chemistry is not a prerequisite for this class, I'm going to keep this super light. You just need to understand the general concept because it's important in some exercise physiology principles we're going to talk about. So the body likes homeostasis, and equilibrium is a form of homeostasis. And we've talked about equilibrium in terms of pressure gradients. There's also equilibrium in terms of chemical reactions. So many of the chemical reactions in your body are in what we call a dynamic equilibrium. Okay, what it means is that these reactions can shift back and forth. Okay, so under some conditions, this reaction can move to the right, which means that hydrogen is binding with bicarbonate ion and forming CO2 and water. And in other conditions, this reaction may shift to the left. And what that means is that water is binding with CO2 and forming bicarbonate ion and hydrogen. The body's goal is to keep the ratio of the reactants and the products, so basically the ratio of both sides of the arrow, the same. Okay? So if something happens to one side, that is going to affect the equilibrium and cause a shift in order to regain equilibrium. Okay, so right now it's probably a little confusing, but let me show you an example. All right, so this is the main chemical formula that we're going to talk about in this class in terms of dynamic equilibrium. And this is going on in your blood throughout your body. So let's go to a more general concept before I explain this specific concept. So here's an example here. So we have both sides of the arrow. Okay, so let's say this was A, this is B, this is C, and that's D. Okay, so here we have A and B, and we have C and D. Okay. And when we're in equilibrium, it means that both sides of this arrow are equal, okay? And therefore we have a balance. You can think of it like a teeter-totter where we're in balance. Okay. Now, if you disrupt this equilibrium, what you're doing is you're adding something to one side. Okay? So if we add to this side, without adding to this side, okay, this left side, the AB side, is going to get heavier, right? It's going to be more. And this is going to disrupt the equilibrium, so we're no longer in balance. And the body's response to a disruption is to create a response in order to regain homeostasis, in this case, regain equilibrium. So in this case, what you can do is you can take one of these boxes and put it on this side. Okay. Now we have regained equilibrium. Okay. Everyone's happy. Okay, so in this equation, we got to think about what's happening in the body. At what point in the body are we adding CO2? And in what part of the body are we removing CO2? So in this video, we're going to focus on the CO2. All right, so this time we are going to take that same chemical equation, okay, and we're going to talk about what happens to this equilibrium as it moves through different parts of the body. Okay, and we're going to focus, all of these things are changing, but for our purposes, we're going to just focus on what's happening to CO2 because that's going to be the primary thing that changes in the blood as we move through the body. So this is capillary blood coming in from the veins. It contains all of these elements, and they are in a dynamic equilibrium. Okay, so everything is balanced. But as the capillaries start to go through the lungs, okay, CO2 starts to diffuse out of the capillary into the lungs, and then we exhale. So what we're doing is we are disrupting the homeostasis. We are disrupting the equilibrium. And what we're doing is the right side of this equation is losing CO2. Okay? Let's just look at the carbon. Okay? It's losing carbon. This causes a disruption of the balance. And so in order to regain the balance, what the body does is the reaction starts to shift to the right. Okay, it's a two-way arrow, but what's going to happen is it's going to go to the right. Okay, this is going to allow some of this carbon to go to the right to replace the carbon that we lost. And once they're balanced again, we're back into equilibrium. Okay, so as the blood goes through the lungs, we lose CO2, which disrupts the equilibrium. And in order to regain equilibrium, this reaction shifts to the right. Okay. This blood, when all of this diffusion is done, equilibrium is regained. That blood ends up in the arteries, ends up in the arterioles, and ends up going into the capillaries that are leading into the cells. Okay. So now we're looking at the capillaries going through the cells. Okay. Again, we have the same elements, and they're in an equilibrium. Okay, they're still in equilibrium because nothing has changed from here to here. Okay, but when we start going through the cells, okay, including the muscle cells, what's happening is that the muscle cells are producing CO2. Okay, and that CO2 starts to enter the capillary. Right. Remember that the PCO2 in the cells, the muscle cells, is higher than the PCO2 in this capillary blood coming from the arteries. Okay, and so we've got a pressure gradient. CO2 is going to leave the cells, and now we disrupt this equilibrium. Okay, because now we're adding CO2, we're adding carbons. Okay, so now the right side of this equation is getting heavy. We need to fix this disruption. The way the body fixes it is this reaction shifts to the left. Okay. So water starts to bind with CO2, and in the process we produce hydrogen ions and bicarbonate ions. We've removed some of that carbon dioxide, removed some of that carbon, rebalanced the equation, we're back into equilibrium. Okay. So this reaction is going to shift in different directions depending on the conditions in the environment. Okay? In the lungs, it's going to shift right to replace the CO2 that's lost in the lungs. And in the muscle, it's going to shift left to remove some of the CO2 that was formed in the muscle. Okay? Now, when you think about this, don't memorize right versus left, okay, because it's actually completely arbitrary that I wrote this equation in this direction. Okay, I could have easily written it the other way around. CO2 plus water, hydrogen plus bicarb. Okay, and so instead of memorizing it shifts right, it shifts left, just think about it. You know, what's happening, which side is rising or dropping, and how does this reaction need to shift to fix the equilibrium.